Yeah, that's me again. So first, let me introduce myself again. Patrick, thanks for the introduction again. You reminded me that I'm kind of old. We actually talked about my first experience with open source when I was working for Nokia in Helsinki. And we were working on Symbian and Maimo. Anyone remembers that? Good. There are some old people here, I guess. So that was the Linux distribution on mobile phones, and that was my, again, first experience with some Linux code and open source, and I really enjoyed it. And I saw a lot of potential there, a lot of interest, great communities, people who were willing to help me out with my challenges, my technical stuff. So when I actually came back from Helsinki, and I traveled through Vilnius back then, and for me it was a completely different city back then. It looks amazing now. So when I got back to Czech Republic, I started working for Red Hat. I was one of the first employees of Red Hat Czech Republic back then. It was awesome time because we basically look at the different communities that we work with in the open source space. We got a lot of people into the office, and we had a lot of great fun. And since then, the company grew. It's a completely different company today. Maybe I should have asked anyone who doesn't know Red Hat and what we do. Good, I don't have to explain it. Perfect. We do a lot of open source stuff, let's put it this way, right? So a lot of open source technologies and a lot of interesting stuff that is happening in the company. What I started doing there, I started as a developer, but I was not the greatest developer out there. And at some point I realized that I can help the people in a different way. I became a tech lead, I became an engineering manager at one point. I was responsible for a huge part of the Red Hat operating system, Red Hat Enterprise Linux. Then I burned out also. I had, again, a lot of different troubles putting certain things through our processes and our decision process especially. And I moved to this thing called Kubernetes. We started with something called OpenShift. OpenShift is our Kubernetes distribution. And I got really excited about this. Interesting stuff, right? Docker started coming up, containers were rising. And one thing that I was really excited about is that with Kubernetes, this idea of each component emitting some signals and talking to each other and basically working with the components in a declarative way, it's really cool. And it gives us some interesting opportunities when it comes to observability and understanding what is actually happening in the infrastructure, what is happening with the applications, and also building some interesting things on top of that. So we actually pitched some idea about what we should do in the Kubernetes space, and OpenShift specifically, about the telemetry stack, how we should leverage that internally so we understand what customers are doing, build eventually even some services for our customers so we can influence the functionality of the platform by the telemetry data that we're getting from them. And I pitched that idea to our CTO back then, and he basically asked me, Radek, what do you think is the biggest gap for this project to succeed? And I was like, well, we don't have any product managers. We don't really know how we're going to position this for our customers, what's the market value and things like this. And our CEO basically told me, CTO, well, you should do this. So that's how I became a product manager. Again, pitched some idea, and then I was told, go build a team of product managers, look at the observability stack that we have, and figure out how our customers can leverage that, but also how we can build internal services and internal things around that. Today, I'm running a small team of product managers, 4 spread across the globe, and we have a team of roughly 100 engineers that are building and maintaining a lot of the observability components that we have in the distribution. Maybe that's an important thing to mention here as well. What we do as a company is we provide a lot of Lego bricks, and then we tell customers what they should potentially build with this, or we tell them go figure this out. It's kind of a DIY story that we're talking to our customers about, because we don't, like in the observability space, we don't have a product, it's rather a distribution of multiple components, and we're trying to make sure that these components are satisfying different use cases. So say we have a customer that is focused on edge or telco, we have something like a blueprint telling them, hey, this is what you could do with our components. But again, we offer you enough flexibility to figure out what you can do or combine other components together and build your own solution, again, based on what we support to them. So again, I'm just explaining, I'm not really working on a product, but a bag of Lego bricks. And Patrick mentioned a thing that I'm also proud of. One thing that I always enjoyed about the open source communities and open source ecosystem was the ability to talk openly about things, share the code, but not only the code, the experience as well, and technology ideas, the vision that we have for certain things. So I've been helping to organize this conference called DevConf CZ, and I realized that we've organized a 17th iteration of it this year. So it's been a while. It's a conference that is very open in a way that we are actually looking at first-time speakers. We are not having any professional services there. We leverage a venue at university, but it's basically really based on people coming in and participating, contributing to a community that forms this conference. So kind of an open source approach to organizing a conference here. You'll be surprised, it works. It's actually an amazing experience. All right, so let's switch back to what I'm going to be talking about here, observability. So first thing, when you see observability, you might actually think of something like this, right? Some dashboards, a pilot, cockpit type of a thing, right? A lot of interesting gauges, signals, things like this. But the interesting thing, of course, is how do you understand and how do you figure out what is the important thing here, right? And what is the correlation between these things? Like what happens if my speed is slow and my attitude is high, but my flaps are in this position, right? So these kind of things, the pilot has to have a lot of subject matter expert knowledge, a lot of experience, understanding what is the important thing, what kind of warning lights they can ignore, and is this red thing here important or not? Is that telling me that I'm gonna crash, or is that okay, right? As a person who doesn't have the experience, you cannot tell. And this is part of the challenge that we have with observability. So what I'm gonna be talking about today are stories from some of the customers that I'm talking to, their challenges with observability. So we're gonna touch on the complexity of navigating things like this dashboard kind of a thing. I'm not gonna mention the customer names, but unfortunately in some cases you'll be able to guess, so don't shout it out loud, like, I know this customer, they are so, no, don't do that. But again, it's based on my experience about what our customers are dealing with. So let's start with this thing. So let's first talk about what is observability, at least for me, right? So there is some definition out there. System property defines degree, how the system can generate actionable insights. How do I understand this? So first, with observability, I want to be able to understand the internal state of a system, right? What is happening with my infrastructure? What is happening with my application, or even hardware? Different layers of the system that I'm looking at. I want to be able to monitor the behaviors. So not only what is the actual state, but how is it changing over the time? How is it reacting to any kind of actions, events that I'm doing with the system itself? Again, talking about different layers here. But not only that, I want to understand, based on some specific use cases and specific understandings that I have around this, I want to understand what is the health of my application or system in general again. What is the performance? Is it performing as it should? Or are there any kind of bottlenecks? Are there any kind of under resources or over resources that it's been using? What is the actual security of that component? Are there any potential holes? Are there any potential issues with how I'm deploying, how I'm running the component? Maybe one thing that I should have mentioned also as well is I'm going to be talking a lot about the perspective that I have with OpenShift and Kubernetes. But honestly, the challenges that we'll be talking about, I think they're generic, right? So you can probably just move them aside and think about it also as stuff that happens outside of the Kubernetes ecosystem. So again, this is how I understand observability. For me, the interesting thing and most interesting thing is probably the last thing down here. I want to be able to make some decisions and actions out of that information that I'm given from the observability stack. And that means I want to be able to make some technical decisions. I want to be able to troubleshoot issues or prevent some issues before they even happen. I want to make sure that I have the right architecture with my components. Do I use, again, the resources that I've been assigned, or do I need to re-architecture my application so it behaves better and does something different? And I want to be able to drive some business decisions as well, right? I want to understand the customer behaviors. I want to be able to prioritize even features. As a product manager, I want to be able to understand what are the features customers are using and how, what are the scenarios, what are the use cases as well. And again, I want to be able to make some decisions on this. Do I have to notify someone if something happens? Do I have to deprioritize feature as a product manager if nobody's using it? Things like this. So again, for me, the most interesting thing is how do I make that action and decision out of all the different signals that I'm getting? Now let's talk about, I'll start with customer stories, right? What if there's no observability? What happens? And it's always great, and I do this quite often as a product manager, not only to think about what is my next feature, how that's going to help me, but what if we don't do this feature? What is the alternative to that? And it helps a lot of the times to understand that there are some things that are absolutely necessary to do, and they have to be there because the other option is just completely wrong. Now, I'm going to be talking about a customer that I visited a couple of weeks ago. They are responsible for the electric grid in UK. And they were basically giving us an example. They are using some of the observability components that we have, and they were talking to us about the number of power producers or solar installations that basically tripled over the last year. Different reasons for that, right? The energy price is going up, but also different subsidies that the government is giving on this. But the customer was basically telling us it has a huge demand on their observability infrastructure when it comes to reliability and scalability of that. They need to react within a matter of minutes on new sources that are connected to the grid, or when basically the energy producing, the solar starts producing energy and it starts peaking, they need to be able to make some adjustments on the grid and prevent basically the wires from ending up in flames, right? I don't know all the details, but the idea was that they were basically telling us if the observability solution that we have right now in place stops working, people will be dying because we will shut down the hospitals, we'll shut down the elderly houses, and we will lose some power. And it's basically almost like a drastic thing telling you, hey, if your product stops working, again, we'll see people that will be impacted by this in a very severe way. So an interesting thing. Now, a similar story happened in North America this summer or this spring, where the southern parts of North America were hit by a hurricane and they lost power. And the company actually that was responsible for that kind of admitted that they don't have any monitoring and they are not able to tell which of the households are already connected back to the grid and which are not. They were not able to really say a portion of our customers are still not connected. And we were like, well, they probably don't have any kind of observability solution there. The interesting thing is that they were able to overcome this, and that's the interesting part of the story. They actually paired up with a company that is selling these fire detectors to houses, and these fire detectors are actually connected to a server of some sort, right? So that company was able to sell them data about which of the household already have energy at home, and that's how they were able to sell. Now, the reason why I'm saying this is also, A, if you don't have observability, you're gonna end up in chaos. But think of all the damage that you could do, right? You could basically have something that threatens the lives of the citizens, but also if you don't have an observability solution in place for your application and your services, there is an impact in the reputation of the company, potential lawsuits. The company in the US, they're going to get sued right now, right? Because for, again, a lot of the customers that were not able to tell when they will recover from the energy, people might have died as well. Think about it again. But so they're basically risking, or they are at risk of being bankrupt because of all this stuff that has happened. Again, missing observability. So chaos happens. Okay, let's talk about other stuff now. So for me, the interesting thing and important thing is when we talk about observability is that this is this continuous virtuous cycle of refining and understanding what I'm looking at. What I mean by this thing is that when you look at observability of, again, the system in general, the first thing you need is that you need some sort of signals, right? So we'll be talking about what kind of data I'm getting, We'll be talking about the classic approach in observability, so we'll be talking about the metrics, logs, traces, but in general, any kind of events, any kind of data that you're getting into the system to help you understand the state of it, right? But then the second part is, how do I understand the data? Again, think of that pilot thing, the dashboards. What are the important things? Is that red thing down there important or not? How do I tell? So the second thing of observability is you need to understand the information that you're getting, and you need to be able to navigate through that. When you do all this, you often realize that you can improve your system just by looking at the observability data. You can improve the architecture of your application. You can, again, better spend the resources that you have available. You can do some changes in the way, again, prevent some potential issues or some behaviors that you don't want to see from the system. So that's the part where you improve the architecture. And this often leads to another step, which is better instrumentation. Oftentimes you realize that all of a sudden these improvements lead to, again, new services being introduced, new things happening within your system, or you're missing some additional information that might improve the overall performance of the system. Third-party data, again, better instrumentation of the application and infrastructure layer. So again, often what we talk to customers about is that you start with something. And it doesn't really matter whether it's really just a subset of information. You start with something, you make sure that you understand this data, and you can make the decisions based on that data, because then you can continue with this. You can add additional instrumentation, additional sources of information, and keep improving the whole system that you are looking at. So that's the vicious circle here. Now let's talk about the challenges. And I promise I only have really 4 slides about this, so let's see how this goes. There are challenges, again, that are coming from customers that we are talking to, and I would say every single customer has gone through different stages of these challenges, of course. Now, the first thing is that we introduced Kubernetes. If you haven't noticed, it's been 10 years already. And it's a cool thing, really, but it's still a very complex system that produces a lot of information, and the complexity is not going away. I would even say that the complexity is getting worse. There are multiple reasons for that. One of the main reasons for me is that when we started with OpenShift, a lot of the customers were the early adopters of Kubernetes, right? And they understood the technology very well, or they were just trying it out, right? And they only have a handful of applications there. It was a new thing for them. But now it became a standard for application platform. And with that, we have customers who, I'm going to say, understand a little less about what is actually behind the scenes, what is making the platform. We have customers whose maturity of their ecosystem has grown as well. So we're no longer talking about a dozen of applications, but we have customers with thousands of clusters, 100,000s of applications, millions of users. So all of a sudden the complexity is much more bigger as well. But also the architecture of the applications, and that's probably what you all experience as well. You can leverage different services, you can leverage different components, and the understanding of these components and what is happening there, they all produce a lot of signals again, and making sure that you understand which of the layers of your applications are telling you what, it's actually very hard. For a lot of the customers, this comes with also a lack of some visibility over all this stuff. They usually have some understanding of a portion of their services or infrastructure. But when you talk to them about how these things are connected, what happens with the application and how does it impact the infrastructure, and how does it even impact some of the decisions that they want to make on the underlying data center layer, how do they do capacity planning and these kind of things, they often have no idea. They're not able to connect the dots really and understand the whole ecosystem that they brought in. I already kind of mentioned the third thing here. Another challenge comes with, and we'll be talking about cost and these kind of things, but the fact that you can choose different architectures of hardware, you can choose your on-prem cluster versus public, you can choose different services, you have a lot of choices. when you build your application, build your service, but they all have some sort of an impact. And again, you need a good observability to understand what kind of an impact you're looking at and how does it influence, again, would it be performance, price, or energy being used, and these kind of things. We'll touch on resource utilization and capacity planning. Again, part of that, how do I use the resources that I have? So again, one of the first challenges that we always talk to customers about is that the complexity of the systems is not going away. And again, with how they mature over the time, it's even getting worse, and good understanding of the whole thing for them is super important. Now let's talk about another challenge that actually comes with this, right? And I already mentioned that. You have a lot of different services, you have a lot of different components, and they are all built in the way that they produce different signals. And you want to leverage those signals, and you're encouraged to leverage these signals. But at the end of the day, it's a massive amount of logs, traces, again, events or metrics that you're looking at. We did an analysis at one point with our customers when we look at how we support them on OpenShift. And we basically realized that there's a certain threshold of number of alerts that the customers are seeing on OpenShift when they open a support case. And it was surprisingly low. Basically, when they see like 5-6 alerts on average, they would go ahead and open the support case. But then we also look at the average number of alerts that customers are seeing when they actually have a support issue with us. And this was around 30. So imagine 30 different alerts from different components, different parts of the system, firing at the same time. And at that point, the customer is basically like throwing the hands up in the air and saying, I have no idea what to do here. I don't understand this. I need some help. Well, the challenge, of course, is figuring out through that volume of data, through the massive amount of signals, what is the most important thing for me? Where do I start troubleshooting, or where do I find that information that influences my decision about, again, the resources that I'm using, how I'm going to be planning my infrastructure and things like this. It's also very hard to understand the dependencies between the components. The way Kubernetes is working is in a declarative way. Different components are trying to basically reconcile in the desired state, which means that you get, again, a lot of signals from the components, and understanding, again, the correlations between this, and correlations not only between the components, but different signal types as well, right? How are my logs connected to the alert that is happening, to the events that customer did, or some action that the customer did with the interface that the service has, right? So understanding all this, super hard. And I already mentioned, where do I start? Where do I start triaging? Where do I start when it comes to, again, cost efficiency sort of optimizations? What's the again, the first signal or the first thing that I'm looking at? So that's another challenge that, again, very often we've been mentioned. Should have told you at the beginning, I'll be walking you through these challenges, but hopefully at the end, I'll be giving you some answers as well. So wait for the answers. Now, the third challenge, again, already kind of touched on that. We see customers that probably someone in our sales department told them that they need Kubernetes and it's a great thing, but all of a sudden they realize that they run 1 or 2 applications there and it's just super expensive for them. And I see customers who've been told to move into public cloud and they struggle with the same thing, right? They have 1 or 2 applications there and they connected all the different services the public cloud provider gives them, and all of a sudden the bill is just crazy and they're like, oh, we thought that this is going to be just running very cheap here. There is a high overhead cost when you run something in Kubernetes, when you run all the services attached to that, and you need to understand that that cost needs to be like substituted or basically compared to how you're using the platform and what are the benefits of the platform that it's giving you, right? Kubernetes is not the best solution when you're running a single web application and you just want to run it somewhere isolated. But again, if you're running multiple applications, high tenancy, if you actually want to leverage the services or microservices architecture, if you want to share those services across the applications, yes, that's a solution for you. With that comes an interesting challenge, right? You have that infrastructure ecosystem of different services, different things running in different premises, usually owned by different teams as well. How do I actually plan for the capacity? How do I decide whether a service needs to be run in public or on on-prem clusters? How do I make the right decisions, again, when it comes to the resources that I'm using? It's super difficult. And again, without a good understanding that what you're actually using and how, you're kind of screwed here. We've seen customers that were able to spend $10,000 and more a month by not really understanding what they're even using. I've seen customers that just started dumping all the logs into AWS because someone told them that they need this for auditing. And they don't really understand the use case of, and actually the cost impact of this. Again, they didn't have a good understanding of this before actually making the decision that they're going to use this service here. Very often what we see with customers as well is that they don't really leverage the resources that they have. I'm going to blame the developers for this. Well, the developers, when you're offered a resource, right? When you offered some beefy hardware, are you going to say no? No, you're going to take all the resources that you can, right? I see this quite often, that the developers would say, I'm going to use these resources, I'm going to allocate this. We have a customer that we've talked to them about how they utilize their resources. And they were basically telling us, we're planning at 50% capacity. We want to make sure that there's of course some spare capacity that we can use, but 50% is where we are. We look at their infrastructure, we analyze the data, and someone wants to guess the number, how great they were. They were basically looking at 15-17% of utilization of their resources. And when their finance people actually saw that, they were just like, well, these teams are actually asking me for more money, but they've been using this super expensive hardware that we have only for, again, 17%. That's crazy. But again, the biggest challenge that the customer had was they didn't really understand the data that they're looking at, and they were not able to make the decisions between the administrators of the infrastructure and the developers on how to basically change the deployment files, how to communicate to them that they should not be allocating that much resources, or on average they're actually using much less, things like this. So very often this also happens that not only they're not able to understand the data in the proper way, but they don't even have the right data. So we've seen customers that made the decisions to change the granularity of the information that they collect and only collect certain events and alerts, certain logs. And then they completely missed some of these interesting things that we talked about, right? So they didn't have the resource data, for example, so they couldn't really tell that their infrastructure is heavily underutilized, because they saw that they don't need this type of information, and they just basically scratched that. So we're also quite often talking to customers about what is your use case? How do you want to use that information that the platform provides you? But also, do you have all the use cases, and do you really understand that there are certain things that you might want to be monitoring for? Again, cost being one of them. And how do I actually, again, produce and process that kind of information that is available there? Comes to the last thing here, which is a customer or multiple customers that already started leveraging a lot of the information that they're getting, but they're hitting another problem, and that's scalability. Because all of a sudden they produce a huge amount of information, but they also have different stakeholders, different people within the company who are interested in the data only for specialized use cases. So I'm talking about the classic like operations team, but they have SRE teams, they want to understand certain things. Developers who are probably interested in the resources and architecture things or metrics that are coming from the applications. But they also have finance people who are interested in specific information, product security or security teams that for compliance reasons need to store all audit logs. And then they have another team that only does this and that. So eventually we see customers who are kind of struggling with one thing, and that's basically I would say like explosion of the observability stack for them. They have multiple tools, different data collectors. They replicate data from different places. We had a customer who even didn't know that they've been replicating logs through 3 different locations because one team started collecting logs for one purpose and the other team started collecting that for a different purpose. And they also replicated that in AWS S3 bucket. And we basically show them in your architecture, we have this and these inefficiencies and basically a lot of information that is being duplicated, leading to, of course, a high cost and an overall like misunderstanding on how the data should be used. Now, the other challenge with this comes with the amount of the data and being able to process that. If you have information from logs again or metrics from Oreo clusters for multiple years now, because you've been running Kubernetes for a while as well, and all of a sudden you want to see some trends. But with the granularity of the data that you have, it's really hard to query them. So there's a lot of challenges, or there are a lot of challenges around how you process that large amount of information. How do you actually even downscale the information and change the volume of the data that you're collecting based on the different requirements? And again, do I need to store every single metric for 3 years, or do I need some aggregation only on a monthly basis when it comes to all data? And is that going to satisfy the use case that I have? Because again, the security team and their audit logs, they might actually want to have all the information because that's some sort of a government requirement. But the SRE team looking at this just to compare how the system looked 3 years ago and how it looks now, they don't need the same granularity. So another big challenge again comes from the fact that I need to look at the use cases, I need to look at who's been using them and how, and then make changes that reduce the volume of the information that I have, introduce some aggregation, introduce some ways how I can look and search this amount of data, and I can still get the right information out of that, because part of that is really, it's slowing you down when you have that level of information. There's a huge security risk with this. All of a sudden, when you have this amount of information and you start sharing it with large amount of users, you can make some customer assumptions. You can even see some sensitive data from your customers. A lot of the customers that I'm working with are basically partners. So they're building private clouds, infrastructure that is then shared across many other companies or smaller like subsidies of these customers. So this is a thing that happens a lot to me when I go to telcos, when I get to go to banks and financial institutions. They have one department that is responsible for the whole infrastructure, but they don't necessarily want to share the data between the different, again, customers, users, clients that they have. And also they want to make sure that even within those customers and clients, they have the right RBAC, they have the right information for the right set of users. So there's a lot of discussion and a lot of work actually happening around how you secure and how you define data privacy and the data security on top of all the observability signals that you're collecting. So again, these are the main challenges that I'm talking to customers about, and let's walk you through some of the projects or some of the things that I find interesting. But before they do so, one thing that I want to mention here and define here is that for a long time, when it comes to observability, we've talked about something I would call the classic observability. It's quote unquote because I don't think it's an established term here. But basically, we talk about these main pillars. We talk about logging, metrics, tracing, potentially some events as well. And all these pillars were kind of disjoint. They had their own data collection, data storage types, and even visualizations were usually very different. What is happening today is something that is defined as modern observability, and these different type of signals are blending in together. There are basically, for me, an interesting stuff that is happening around traces and open telemetry we're going to be talking about this. But the idea is that all these signals are now being merged, aggregated together. They are being enriched with different type of information and different type of data. They've been correlated across, again, these different pillars. There are ways how you can dynamically change the volume of the data that you're, again, collecting for different type of signals. Dynamic volume management is awesome because some of the work is happening around troubleshooting, as an example. An alert can basically trigger a different collection of additional signals and change, again, the volume of logs that you're collecting from a component based on an information you're getting from a different source. So modern observability, just making sure that we understand each other. It's a lot about merging these signals together and understanding them as a complete thing, but it's also a lot about how I process the information, analyze it, and what kind of outcomes I'm getting from this. Now, here's an interesting thing. When you look at CNCF, Cloud Native Computing Foundation pages, they have tons and tons of open source projects when it comes to observability. So what I was explaining at the beginning, my kind of a role at Red Hat is to pick some of these components and figure out which one do we offer to our customers for what use cases, how we're going to support them, integrate them, and things like this. So what I'm planning to do right now is I'm going to walk you through a couple of components that I find interesting, and you should pay attention to this. But before I do so, I'm just going to tell you that if you look at what is happening in the whole observability ecosystem in CNCF, it's a super active community. There are a lot of projects, including Prometheus, including OpenTelemetry, again, we're going to mention that one, that have a huge number of developers and companies backing it up and interested in that. And again, the reasons are basically all these challenges their customers are facing. So you're going to see a lot of different projects happening there and a huge development there. So I introduced the concept of modern observability. For me also, the change is that we're no longer talking about the pillars, but we're talking more about layers. And the layers that I'm going to be quickly mentioning here is that you, of course, always need some data collection and data storage layer, how you collect and store any information, how you process it, so some processing layer on top of that, what kind of aggregation and correlations you can do with the data. Then I'm going to show you something that comes with like integration. You want to expose that information into a tool that you've been already using, or some of the UI visualizations, or some other tools that can actually use that information for some sort of a decision. How do I integrate this with things like ServiceNow, Slack, and things like this? And then I'm going to touch on the analytics part. What kind of projects are there that analyze different sources of data and actually come out with some interesting findings? Now, you might have heard about Prometheus. That's pretty much a standard for monitoring and alerting. I wouldn't talk much about it. Kind of the same thing with the Grafana Loki stack, which is focused on log aggregation. And you might have seen Grafana as a dashboarding tool as well. It's pretty awesome. But OpenTelemetry, if you haven't heard about that thing yet, I highly recommend looking at this. OpenTelemetry is right now the second largest CNCF project, second most active CNCF project. And it's actually a very interesting thing. It started from the tracing perspective. Traces are basically, for me, logs enhanced with some sort of a metadata. I can look through the span, I can look through the different events, different type of messages or data actually through the whole system, through the whole application. And I have a lot of metadata about where is it coming from, how it was emitted, how is it connected to the next thing, and stuff like this. So for me, these are logs enhanced with some metadata and some additional information. The OpenTelemetry concept basically picked up this kind of an approach and introduced, I'm going to say, like 4 different things at least. There is an OpenTelemetry collector that is able to process and collect information from different sources. There are the sources, which are usually some data schemas on what I should be collecting from different sources or different places on the system or different applications. There's an auto-instrumentation concept, so basically an idea of I'm running a specific framework, language, database, or something else. OpenTelemetry collector can download a schema that is aware of this. So again, I'm running Ruby, Mongo, Rails, something. There are all the definitions out there in the community page that will give you the right type of signals collected through OpenTelemetry. And then there are even SDKs, so you can bake it directly into code as well. And then there is an OpenTelemetry protocol, which is pretty much a standard right now for different integrations. So if you look at different monitoring tools out there, Datadogs, Dynatrace, and whatnot, they usually standardize on something called OTLP exporter or OTLP import, ingest data ingestion. So both exporting data in OTLP, but also ingesting data in OTLP. So you can actually hook the system into these different monitoring tools. For me, this is an interesting thing because for a long time, there were different efforts to standardize log aggregation. Logs were like the main thing. But then again, with tracing and monitoring, the scope of this problem expanded because also all of a sudden you had also different type of signals, and there was no standard protocol, no standardization around this. And again, OpenTelemetry is getting into this, super interesting. We're doing a lot of work to get it more integrated in the OpenShift ecosystem as well into the products. But I, again, suggest this as something that you can deploy not only on Kubernetes. The collector just works on any kind of Linux distribution. There's a Windows collector as well, and you can start working with the data from this. So one interesting project to absolutely pay attention to. Another one that I find interesting is called Persis. If you've used some dashboarding and UI projects before, you might have used Grafana, which is really beefy, really great. Okay, Grafana has some challenges because they did some changes to the licensing and it doesn't really allow us to do certain things. But if you're looking for a very simple dashboarding tool that you can also define these different dashboards as a code and you can integrate them within your product, you can even put your own chroming around it on visualization so it looks like part of your product. This is a really cool thing that we're actually starting to look at and integrate into our products as well. The idea is that the observability signals for me, they don't need to be as on a side in the dashboarding tool. They usually make much more sense when they are part of a certain workflow where they give you the right information within these different products that you might have also. So this allows to do exactly that. Another interesting project happening upstream, Correlator. I talked about one challenge that we have, and that's signal correlation, understanding if I have an alert here, what kind of logs and what kind of events actually are connected to this. So Correlator tries to do this based on some set of rules. It's a time-based, context-based thing, so there are different things, how they actually look at, again, the different sources of signals. And the idea is that at the end of the day, you're able to navigate yourself through the alerts, through the logs, through the events, and see how they're connected. And with that comes another concept that the project introduced, which is an incident. An incident is basically a grouping of multiple things together. So I was telling you the example at the beginning where customers open a support case when they have 15 alerts. How are they grouped together? It was hard for them to tell, and also it was hard for them to tell what is the one root cause of the issue, right? You might have heard the joke, it's always DNS, but okay, if it's something else. So the idea is that they introduce this concept of incident when they group these different signals together and also give you the most probable thing that is causing this. And I really love it because from these 15 different alerts, it can give you 3 basically and tell you these 3 components is where you start your troubleshooting. Don't worry about the rest, but these 3 things. Honestly, it's still better than what we had before, right? It narrows down the scope and it gives me some better visibility into what I'm looking at. So another really cool, interesting project. I have another one here, and I'm slowly running out of time, so I'll speed up here. Sustainability, a big topic, especially in the European Union for the last couple of years already. But here's the thing, if you're looking at how you optimize your system, you might have 2 approaches, right? You're looking at cost and how much it actually costs you to run these different projects. Or another thing is how much energy you're actually using for your workloads. The Kepler project, it's part of the sustainability computing thing, is basically looking at, again, the consumption, the energy, the resource usage of your workloads, and then there's some magic with looking at the CPU that you're using and some other stats from your system. It has something called estimator. I don't think I mentioned here. So based on the machine learning model behind that, it knows about different type of infrastructure you might want to deploy the workload on, and it gives you some energy data. For me, the interesting use case for this is when you actually do some sort of a change on your system, in a way how you deploy your service or re-architecture thing. You don't use JDK, you use Quarkus. You want to see whether this kind of a change actually had the energy impact as well. So we were running an example where customers started using service mesh, right? So they were using the serverless workloads instead of server full, but because they only were using 2 very small workloads there, we realized that the overhead energy that the actual project is causing there is not worth it. it was much easier and much more energy efficient for them to just run them as a server full workloads and not have, again, Istio or whatever they were using behind that. So again, it's an interesting, when you do an architecture change, you might want to understand also what kind of an impact do you have here. I'm gonna mention AI, right? Everyone talks about AI, and I realized that even here I have to talk about AI. Gen AI is cool in observability space. We look at that and we were like, it's not ready yet, but we have a project that is open source right now, called Lightspeed. It's more focused on explorability than Gen AI use cases, to be honest. So it's gonna tell you, if I have this pod on my cluster, it will give you the right information that are related to that pod, what kind of information and signals you're getting from the different parts of the stack. The idea is, and it's not implemented yet, is that thanks to things like Radek, we'll be able to augment the prompts with some observability signals. So again, when you think about the open telemetry stuff and a lot of metadata that are coming with the signals, how can I use this to augment the prompt so I get the right information about what is the problem with my workload, why is it not performing as it should, and things like this. Something, again, that is still evolving, but definitely worth exploring. And I'm gonna mention this one more thing here, and then I'm pretty much done. A lot of the components that I was showing here, again, it's hard to set it up and connect that, right? I wanna be using the different signal types. I wanna make sure that I have the right collectors, the storage, but I wanna make sure that I leverage also the analytics features and maybe UI integrations and whatnot. So we've actually started at Red Hat working on these things that are generic for any Kubernetes distribution. And the idea is that these are observability operators, a way how you deploy multiple components together with some opinionated or default configuration for different signal types. But also we'll be able to choose or propose to users what kind of analytics features and components they should be getting when they have all these different signals. And again, the idea is that things like that I was showing you, the correlator, the incident navigation, you'll be able to say, I'm running logs and alerts, I have this and this stack, and this component will tell you, okay, we're giving you correlator as well because you already have all the signal types and you can work with this. And something similar happens in the multi-cluster space, but I'll skip that. One last thing at the end. So what we have learned from all these customer challenges. So the first thing for me is still making sure that we have this unified view across all the different signals that we have, and we really understand the different use cases that we have for these signals, right? So it's not only the amount of data that you're getting, but how you want to use it, how you want to treat it. It's super important to understand and deal with the signal fatigue. Basically, there's a lot of signals. We need to be able to reduce the noise, automate different features out of this, automate troubleshooting, proactively solve problems, or do decisions around resource and capacity planning. That's the other thing, resource control. Huge issue. Again, I need specific type of data for this. I need understanding over a certain period of time on how the workloads are running. And I need to be able to make decisions that are either impacting the cost of the infrastructure or the energy that my infrastructure is using. And with that comes a scalability and governance thing. So I need to be able to run this observability stack in a way that, again, it can process all these different signals, but also it gives me enough data security, data privacy things, so I know who's been accessing the data, how they've been using it, and so on. Last famous words, we love open source. All these components that I was showing you, they're all open. Some of them you will find on CNCF, some of them directly on GitHub, but I will encourage you, if you have some ideas on how you want to deal with observability, go check these first and contribute to something that already exists. There is a high chance that somebody is already working on that. With that, I'm pretty much done here. I'm out of time, thank you. And we still have some time for questions, right?
Yeah, we'll do some rapid fire questions. I'm gonna run all the way there.
Hello. So, from your experience, what's the final cost of observability, the overall cost of your deployment?
Overall cost of observability or final cost. I don't have a good answer for that. That's something I should look at, to be honest. But the truth is that, again, when I work with some of the customers, it can be anywhere from as same as the cost of the infrastructure to 10 times more than what the infrastructure actually costs you. And again, it really depends on how you process the data, what kind of amount of data do you have, and have you purchased a service that is hosted and data ingestion is so like super expensive. So I don't have a minimal cost, but I know that it can go super high, and that's the danger.
All right, more questions over here.
Thank you for your presentation. I have a question about this noisy stuff, noisy logs, a lot of them. Which way, in your opinion, is preferable to reduce number of signals and make it like one understandable number? If it reads, it's bad. Or provide like guide or troubleshooter for users to prevent these problems in the future and maybe to add more understanding of the system at all for users.
Right. So what I've seen from, again, some of the customers, and usually this is coming from the SRE teams that are dealing with the infrastructure, they start with usually whitelisting the most important information for them, right? So they observe the whole platform, usually on the individual cluster level, and then they say these kind of things, these kind of alerts or signals, we want to correlate, we want to aggregate first, we want to show in our interfaces, and then this is, again, the iterative process that I was showing at the beginning, right? Because oftentimes you realize that you've introduced a new component, you have a customer with new type of workload, and I need to extend that. So I've seen, again, working with the whitelists, but continuously re-evaluating, that's an awful word, what you have there. Do I still need the metrics that I'm getting there? And should I be adding something more or even removing things? And the second thing that I was talking about is aggregation and dynamically changing the volume of the data. So again, as an SRE, I don't need the same granularity of the data for last week that I need for 1 year, right? For last week, I probably need every single metric change in my Prometheus. But when it comes to 1 year, I can aggregate the data and I can find a different way how I store that information. By the way, Prometheus is not good for the data aggregation. It doesn't really do that. So you need a system outside of this. And this is where I've seen customers usually coming up with their own data processing pipelines and using things like Parquet files and just cherry picking data into a different database of some sort, right? And then exposing it for different users. So when I was talking about like the finance people and these kind of things, they usually run some sort of a Argo pipeline of some sort, right? Process the data, inject them in a different system, and then work with them in Power BI or whatever the finance people are using. Hope it answers the question.
So this might be a little bit of a duplicate from what the last person asked, but I was thinking about observability from the point of how to introduce observability into existing projects, existing infrastructures. How do you introduce it as a mindset to existing teams?
First, you need to scare them with the stories that I was telling you here. But the second thing is really, this is where a lot of the customers, again, started the observability when they realized that they have something that is out of their control. And usually that was the cost of something. Would there be cost of labor or cost of infrastructure, where they didn't understand why is it going up or what can they do to actually reduce that. So I would say scare them. That's the first thing. Second thing is introducing a platform that is really easy to inject into the existing applications. And this is where I like the concept of open telemetry, because again, I have instrumentation that is detached from the application. If I have a known framework or something, I can basically define a data schema on the side, and I can use that standard tool, open telemetry collector, to process the information. I don't need to re-architecture anything unless I really want specific information, specific data. I can start outside of that application. Now the open telemetry thing, this is not for your question really, but we've talked about AI again. If you look at the AI LLM frameworks that are out there and different people are working on different stuff, Mary in the morning was talking about Log4Chain and these kind of things. They standardize on open telemetry right now. So that's another thing that the new projects, new frameworks that are out there are actually leveraging this. And it's then very easy for you to just say, you're using a standardized framework, already having OpenTelemetry instrumentation. I'm just gonna introduce the stack here on the side, start monitoring what you're doing, how you're using the resources and whatnot, and then talk to the developers and then talk to them about what you see, how you understand the data, and whether they have the same expectations as well.
Thank you.